So today we're going to be doing something called completing the square, and I just want to say something real quick. You don't need to write this down, but what we're doing is we know standard form of a quadratic. Now remember, quadratic means the polynomial is degree 2. The highest degree is 2. Standard form of a quadratic is y equals ax squared plus bx plus c, right? We know that, right? That's what we were using and then factoring. So what you can do is you can rewrite this in a different form, and it's going to be called vertex form. And it's going to have this form instead. Y is equal to a times x minus h squared plus k. And this is called vertex form or graphing form. It's a lot easier to actually graph. Like you're going to, like graphing a quadratic in standard form was kind of the process. Graphing it in vertex form is super easy. We're going to learn that a different day. But that's why we want to be able to take this and change it to vertex form. It's because then it's really easy to graph and they're even easy to solve. Okay, so we're going to fill in. You have this thing on your notes. So we'll go through and fill this in real quick, and we'll just keep practicing it. So we're going to put a perfect square. So this is called, when we take it from standard form to vertex form, we're making it a perfect square. So a perfect square is a quadratic function that's written as x plus 3 times x plus 3. Now the reason it's called a perfect square is because aren't squares length times width? Squares look like this, correct? So won't our length and width be the same, you guys, on a square because the dimensions are the same? So do you see how if you have an x plus 3 and an x plus 3, those are the exact same thing, just twice. Everybody go to that. That's what makes it a perfect square. So it says the factor is squared, or I've said 2 binomials being multiplied. So let's just write, because let's not get into too difficult terminology. 2 things, let's say 2 exact, I'm going to say 2 exact things being multiplied. Does that make sense, everybody? 2 exact things being multiplied. And it can also be written, so understand if you have x plus 3 times x plus 3, that's the same thing as x plus 3 squared. Does that make sense, everybody? Does that happen twice, so x plus 3 squared? You all good with that? That's the same thing as x plus 3 times x plus 3. Okay, that's all on your notes. Now it says not all quadratic functions are perfect squares, which is true, but we can force any function to look like a perfect square. That's taking it from standard form to vertex form. And this method is called completing the square. So completing the square. All right, so we've got that on our notes. All right, everybody good? Moving on to the next piece of your notes. So it says, to start, we'll be trying to determine the value of c that makes the equation a perfect square. So what we're going to be doing is we're just going to focus on the first 2 terms, the x squared and the 6x. We're going to focus on those 2, and then we're going to really focus in on that middle term of 6x. And then we're going to take and complete the square. I teach this a little different than how this teacher, because we take turns like helping each other type up some notes and stuff. So I teach it a little different, so we're going to kind of go off to the side, because my way is a little bit easier. So what we're going to be doing is completing the square. So this is what your square is going to be. Everybody write this down. So we know quadratics, first of all, have the form ax squared plus bx plus c if it's in standard form. What we're going to do to complete the square is we're going to take our b value, our middle term. We're going to take b. We're going to divide it by 2. Now b is just the coefficient in front of x. Does everybody see that? So we're going to take b divided by 2, and then we're going to square it. That's how you find the square that you're going to insert in. So let's just complete the square. We're going to answer this question real quick. So we have x squared plus 6x, and then basically right now we have plus 0. C is 0 because there's nothing there. Does everybody see that? Okay, sorry about that. So let's do this one. So our b value in this is 6. So we're going to do 6 divided by 2. B divided by 2, so 6 divided by 2, and then we're going to square it. We're going to show our work because we're going to use all of the work to our advantage in just a second. What is 6 divided by 2? 3, right? Does everybody see where I'm going with this? So we have a 3 squared, which is 9. 3 times 3 is 9. That's what 3 squared means. So that is the square. So what we're going to do is then we're going to add 9. So add 9. And what we're gonna, so that's the value of c that will complete the square. So right, do you see how down here, let's skip down to right here. So we're adding 9 because we're adding our square. Does that make sense, everybody? So we're adding our square in. And now, because we chose to add in 9, it's going to factor to b. Now I'm going to just show you this one time only. So now notice the reason we chose 9 is because this is going to make this factor to be a perfect square. This is going to factor to be x plus 3 times x plus 3. Now we could go through and factor it. So I'm going to show you. X squared plus 6x plus 9. So remember back to factoring. What multiplies to be 9 and adds up to be 6? Wouldn't that be 3 times 3? 8 times c, right? That's how we know how to factor. We just tested. We did pretty well. So then we would drop down our end terms. So we have an x squared. We have plus 9. And then we're breaking down the middle term as these two factors. But with x's, so we have plus 3x plus 3x. So then we factor by grouping. In common here is an x. Left is x plus 3. In common here is a 3. Left is x plus 3. So we factor out our safe haven of x plus 3. And left is x plus 3. So do you see how that made that 9, that square, made this factor to be a perfect square? We just talked about how that's a perfect square, because isn't that just x plus 3 squared? Does everybody understand how we just found what value made this a perfect square? Okay, so let's practice another one. Now, I want to show you a really cool trick. We're going to use this trick so we don't have to factor this clear down every time, because we don't want to take extra time. So here's a trick. Notice something. You see how this became x plus 3 squared? It was plus 3, right? Everybody, plus 3? Look in here. You see in our parentheses how that was positive 3? That's what it's always going to factor to be. It was what was simplified before you squared it. Does that make sense? Okay, awesome. So we're just going to answer the question. It says, what value of c makes this a perfect square? Our answer for that was 9. So we didn't have to keep factoring it, but this first time I did just to show you. All right, let's answer that again. Oh, no, wait. I think it's going to keep going on. Okay. He teaches this so differently. Okay, so what we're going to do is we're just going to go for it. So let's start with number 4 on the examples of the teacher worksheet. Here we go. So it says, what value of c completes the square? So basically, you're finding what makes this a perfect square. So you'd say to yourself, okay, square. We know that you do b to find what will make this a perfect square. You take your b value divided by 2 squared. That's something you'll have to have memorized. So let's show our work. What's b in this one? 6, right? b is what's with x. So we're doing 6 divided by 2. We just did this one squared, which is, what is 6 divided by 2? It's 3. 3 squared is 9. So we're adding our square. So we're adding 9. So c would be 9. So let's do number 5. It says, what value of c makes this a perfect square? So we're going to we know that the square is b divided by 2 squared. We're showing our work. So negative 32 is b, right? So negative 32 divided by 2 squared. I'm showing my work. What's negative 32 divided by 2? We all have a calculator. 16, awesome. So we are doing 16 squared, which is what? And we can type it in as 16 times 16. 256. So what we're adding is 256. That's our square that we're adding. Does everybody understand? So right here, we do the same thing. We'll do b divided, our square is b divided by 2 squared. So that's 4 divided by 2 squared, which is 2 squared, which is 4. So our c value is 4. That's the square that we're adding. So one more. We know that the square we're adding is b divided by 2 squared. So that's negative 24 divided by 2 squared. Divide those, isn't that negative 6? Nope, I'm wrong. It's not negative 6. Negative 12. Make sure we write in negatives and positives here. So it's negative 12 squared, which is 144. You got to type it in with parentheses into your calculator, like parenthesis negative 12, close your parenthesis, raised to the second power. Or you could type in negative 12 times negative 12. Does everybody understand? So it's positive 144, right? So we're going to, our c that we're adding, our square that we're adding is positive 144. So I'm going to let you guys practice 1 through 4. and then we'll start applying this. And I'll show you how it works. So what you're doing is you're finding the value that we're going to be adding, the square. That you'll be adding to your equation. So you'll do 1 through 4 on your practice now. So you have a practice and we have the teacher notes. Go to your practice and do 1 through 4. So now I want you to look up here because we're going to be looking at something a little different. So on those examples, we were just finding the value that completes the square, you know. But notice something about all those first problems. This is what we were looking at on number 1. See how I said plus C? We found that value. So really you're starting out with something like this technically because we don't know what C is. You know what I mean? So we're calling it like 0 basically. X squared plus 2x. And then we're just adding in something of our choice. The b divided by 2 squared, we added on. Now understand, now we're going to go to ones that actually have an equal sign. So if we had something like x squared plus 2x, let's say we already had a c, for example, plus 1 equals, and let's say 3, for example. Notice the difference. This has a constant. This already has a c, correct? And then we have something over here, and there's an equal sign. So now it just changes it to be a little different. We're going to use the same thing. We're going to do the same thing. We're going to complete the square, and we're going to just kind of shift this over. So we're going to basically shift this over and say x squared plus 2x plus c, and then we still have plus 1. Do you see I'm just putting this right here? And then we still have plus 1 equals 3. So then we'll still do what we just did a second ago and complete the square for this portion. But then we'll just finish simplifying it, and I'll show you what I mean in just a second here. Okay, so let's just get to an example. So rewrite each equation by completing the square. So what we're going to do is we're going to set this equal to 0. So to do this, we've got to set it equal to 0. Is everybody good with that? Okay, now because technically if there's nothing there, we can say it's equal to 0. Does everybody understand? Everybody good? Okay. So we're going to rewrite this by completing the square. Okay. Sorry, I just want to make sure I don't confuse you. So we're going to focus in on this piece, and we're going to do, like I said, we focus on that piece, and then we're going to really focus in on this piece. So we're going to find the value that completes the square by doing b divided by 2. Why did that be funny? Okay. B divided by 2 squared. So let's figure out what we need to insert this in instead of that 11. To make it be able to factor to be a perfect square. So you'll do b divided by 2 squared. So we're going to show all our work because we're going to use it especially in this one. So b is 10, so we're doing 10 divided by 2 squared. Isn't that 5 squared? 10 divided by 2 is 5, which is 25. So before were we adding 25 up here? Yeah, just a second ago, isn't that what we were doing, was adding c? So what you're going to do is you're going to add 25. Now understand, if you add 25 to this side of the equation, you've changed it now, correct? The other ones didn't have an equation, so we could just put it right in there. We didn't have to worry about anything. But where this has an equal sign, you've now changed the problem, which isn't allowed. So what you got to do is you got to do it to both sides of the equation. Just like when we're solving, then we have to do things to both sides of the equation. Yeah? So we're going to also add 25 right there. You see how I did it to both sides of the equation? So I've done it evenly to both sides. I haven't changed it now. I've just, I manipulated it, so to speak. So remember that we're really, I'm going to rewrite this one more time. Remember, we're really looking at n squared plus 10n. We just added 25 in, so I'm going to put plus 25. Then we still have minus 11. And that's equal to, what's 0 plus 25? 25. Okay, so now we're going to focus on these 3 pieces because that was what we did, was we completed the square just like a second ago. Now just focus on those and we're going to factor it. So I'm going to just, I want to keep doing my work underneath here, so I'm going to get rid of this for a sec. Okay. So now, is there anybody lost? So I'm focusing on this piece and I'm going to factor it. Because didn't we just make it be able to factor to be a perfect square, just like we did a second ago? So now we're going to factor it. So we know this is going to factor to be. Let's do our trick so we don't have to go a times c and add up to b. Let's use our trick. Don't we look back inside our parentheses, the simplified form before you squared it? Isn't it positive 5? So this is going to factor to be x plus 5 times x plus 5. Does everybody understand? So now we took care of those three things. We rewrote it in factored form. Those are n's. X is n's. Who cares? Does that make sense? It's just a different variable. I messed up, but it's okay. Okay, and then we still have, so now I'm going to actually rewrite that. We know we can rewrite this as x plus 5 squared, right? Everybody good so far? And then we still have minus 11, and then we have equals 25. So now it says rewrite each equation by completing the square. So we've got this far, we're almost done. So we have one last step. Normally up here wasn't it equal to 0? So we need to fix this to be equal to 0 instead. So we're going to bring 25 over using algebra. So let's subtract 25 from both sides of the equation. So I'm going to come up here, I still have this x plus 5 squared, and now I'm going to do negative 11 minus 25, which is negative 36. And that's equal to 0. So that's when we know we're done. So here's our polynomial. Polynomials are written y equals, or here's our function. So this would be our answer. Everybody understand? It just is going to take a few more practices, but it's pretty, you'll be like, okay, I got it. It just takes a couple practices. So kind of a process, right? Yes. No. So I erased that because see how we just did that so that we could then complete the square. So this is our final answer for just rewriting it. Does that make sense? Good question. Okay, let's do number 9. Let's do another one. And I'm going to need more room to show my work. I'm going to erase that. Here we go. So here we go. So the first thing we do is set it equal to 0. So we have m squared minus 8m is minus 9 equals 0. Now I'm going to actually do this a little differently and see if this makes it easier for you. So the first thing I'm going to do is let's isolate these two things because now we're going to focus on those two things anyway, everybody. So let's bring the 9 over this way. This way there's not so much to think about, actually. I should have taught it like this. So because we know we're going to be focusing on these two, we're going to bring the 9 over this way using algebra. So I'm going to add 9 to both sides. So I have m squared minus 8m equals 9. Is everybody good? So now we say to ourselves, we want to complete the square so that we can factor this to be perfect squares. And so we take our b divided by 2 squared. So that's negative 8. Isn't that b? Negative 8 divided by 2 squared. We show our work because we're going to use our work to help us use a little trick. So negative 8 divided by 2 is negative 4 squared. Negative 4 squared is 16. Okay. So what we're going to do is now we're going to add that in, correct? Well, we've got to do it to both sides of the equation. So now you're going to say, okay, I'm going to add 16 to this side, so I've got to add 16 to this side. That was a lot easier, actually, than the other one. Is everybody good? So now over here, we are going to factor it. We know we can use our little trick. We just made it factorable to a perfect square. That's what completing the square does. So you look back in your parentheses, the simplified answer. Do you see how that's negative 4 is the most simplified answer inside? So this is going to factor to be 2x minus 4 is being multiplied. Minus 4, do you get why I'm doing minus 4? Using that trick. So that's really x minus 4 squared, right? And that's equal to, and then over here we have 16 plus 9 on this side of the equation, which is 25. So our last step is to bring 25 over so that it's equal to 0. Do you see where I got 25? I just added the other side. So I'm going to subtract 25 from both sides of the equation. So we have over here x minus 4 squared minus 25. Now it's equal to 0. So now we can say, okay, our final answer then is y is equal to x minus 4 squared minus 25. Is everybody good? Maybe one more example and let you practice, or yeah, maybe one more. You're good? You want another one? I have more on there, as you can see, because I thought we might need one more. Should we just do one more, and then I'll let you just go for it? You should be able to still finish it in class. Okay, awesome. Let's do that. I'm going to hurry and get back where I had. There it is. Okay. So let's do number 10, and then I'll let you go for it. So we will rewrite this in vertex form. So our first thing is set it equal to 0. And then remember, we're going to be focusing on these two. So we don't want to have to deal with 36. So let's bring positive 36 over here so that we can just focus on these two. So let's subtract 36 from both sides of the equation. So on this side, we have m squared plus 20m. And that's equal to negative 36. And then that makes it easier because I can just focus on the two I need to focus on. So I'm focusing on these two. I'm saying, how can I make this factor to be a perfect square? So we do b divided by 2 squared. B is 20. So 20 divided by 2 squared. We have 10 squared. So 20 divided by 2 is 10, which is 100. That's what we're adding in, just like we were doing a second ago. So now we're going to add 100, but we've got to do it to both sides of the equation. So I'm going to add 100 to this side. I'm going to add 100 to this side. We're adding our square to both sides. So now we know that this side is going to factor to be what was inside our parentheses before we squared it, right? So doesn't this side, we can just easily use our little trick. Look right here. It's going to factor to be m, positive 10, right? So it's going to be plus 10 squared. Are you guys good? And then over here, we add those up, and we get positive 64. So we have equals 64. So now it says, what is the equation of the polynomial? So we don't want to equal to 64. We want to equal to 0. So we'll subtract 64. So that it gives me m plus 10 squared minus 64. Sorry, minus 64 equals 0. So now we've rewritten it in a good form here, and we have y is equal to m plus 10 squared minus 64. Now, I just want to make a point. Didn't I say that? So we started out with something in standard form. Let me show you, because this is going to make a connection. This is in standard form, right? Now we took and rewrote it in vertex form. Look, you see how this has the form x minus h squared plus k. You see how it looks? The same form. And that would be really easy to graph, which we're learning it in Sunday. Is everybody good? You want ready to practice on your own, or do you want another one? Okay. Okay, awesome. I'm going to have you do on your paper, I think it's 5 through 8. So do 5 through 8. I'm going to go back and leave out my example for you. To solve. So I'm just going to go back and show you one that we've already completed the square for. So just look right here. This is on your example theme. Remember when we got to this step, how we then brought 1 over when we were writing out the equation? So with something where we're solving, we would have y is equal to x plus 3 squared, and then we know that was minus 1, correct? When solving something like this, what we're going to do is set it equal to 0. And then solve. So we're going to bring 1 back over. Does that make sense, everybody? So notice we could have just started here and continued, because our first step would be to bring 1 over. But I wanted to show you how to solve something that was like this. So we would add 1. So let's all write out. We have x plus 3 squared is equal to 1, because we would add 1 to both sides of the equation. Now are we trying to solve for x? We need to get to x, correct? Now, x is trapped inside these parentheses with this square. To undo a square, you can do the inverse of a square, which is square root. So if you do that to this side of the equation, you want to do it to this side of the equation. Does everybody understand? So now over here, root cancels out with power. Square root cancels out with the square. So that leaves me with, on this side, x plus 3. Does everybody understand on this side? Now over here we have the square root of 1, so you're going to take your calculator. Let's all practice typing this in. You'll go second square root of 1. We hit enter and get 1. So do you see how we've simplified the square root of 1? Now here's one thing you can't forget. Anytime we're taking a square root of solving, we have to put plus and minus the answer. So we have plus and minus the answer of that, which was 1. So we're going to have two solutions, which makes sense because all of our other quadratics have two solutions. So then from here, we'll split it up. This is really just x plus 3 equals positive 1. So I'm just going to write 1. I'm going to have that, and then I'm going to go over here, and I'm doing a bulletin point, just showing my work. We also have x plus 3 equals negative 1. Does everybody understand? And now we'll just solve for x using algebra. So let's get x alone over here. When we subtract 3, so we get x over here equals, and then add those up, you get negative 2. There's one of our solutions. Over here, we're going to get x alone by still subtracting 3. So we have x is equal to negative 4, correct? When I add those up, I'm going to get negative 4. And there's our two solutions. So honestly, if you ask me, that's easier than solving by factoring. But it just depends on the problem. All right, so here we go. Let's do a couple examples, maybe like just 2 examples, and I think you'll be good. So I'm going to erase these so I have some room, because we're going to need to show our work. So it says solve by completing the square. So we're going to go through and complete the square, and then we'll continue to solve it. So we know when completing the square, the first step we do is isolate those. So we'll bring 24 over. So we'd add 24 to both sides. So then we have n squared minus 10n is equal to 24. Then from there, we're completing the square. So we're focusing in on b. So we're doing b divided by 2 squared, which is negative 10 divided by 2 squared. Show your work. What is negative 10 divided by 2? Negative 5. Negative 5 squared. Don't square this twice. Negative 5 squared is equal to 25, right? So we would now add 25 to both sides of the equation. So I'm adding 25 right there, and I'm adding 25 right there. So now we can say, okay, awesome. Now that we have this side, we can factor it because we just made it a perfect square. We look back in our parentheses before we squared it. It was negative 5. So this piece is going to factor to be n minus 5 squared. We took care of this side. And now over here, you add those up and get 49. So I'm not going to bring this over because then when we bring it back over with solving, guys, when solving, don't we first get that over and then square root it? So from here, we're almost done. This one's not writing out the equation, it's solving it. Does that make sense? So we could bring 49 over and then set it equal to 0, but then we'd have to bring 49 back over. Does that make sense? So I'm just going to keep going from here. So now when we just need to, you'd look and say, I need to get this n alone, so it's trapped inside the square. What does a square? A square root. I got to do that to both sides of the equation. So on this side, root cancels out with power, leaving me with n minus 5. Now you'll take your calculator, type in the square root of 49. 7. So we get plus n minus 7, right? So then we'll split it up. So we have n minus 5 equals positive 7. And we also have n minus 5 equals negative 7. Okay, so now solve for n, just using algebra. So we'd add 5, 12. So n is equal to 12 is the solution. We'd add 5. So n is equal to negative 2 is our other solution. Do you guys feel good? Do I need to keep doing them? Do you feel like you're good to practice for a while? And then I can help you individually if you need. Okay, let's do that. So you're just going to do problems 13 through 18 on the practice, I believe.